Hello, everyone. Today we are going to study distance problems. These are all based on one simple relationship. Distance equals speed multiplied by time. Once you understand that, all the problems we do will become much easier. There are two main ways to solve these problems. One is the equation method, where we assign variables and set up equations step by step. The other is the reasoning method, where we think about the situation logically, comparing times, speeds, and distances without writing equations. I will show you both methods for each problem so you can see how they work. Let's start with our first problem. Max leaves home at 8:20 in the morning and walks to school at a speed of 100 meters per minute. School starts at 9 o'clock, but Max arrives 3 minutes late. How far is it from Max's home to school? From 8:20 to 9 o'clock is 40 minutes. Since Max is 3 minutes late, he actually takes 40 plus 3, which is 43 minutes, to get to school. His distance is speed times time, so 100 times 43 equals 4,300 meters. So the school is 4,300 meters from Max's home. This is a simple problem to warm up. Now, the second problem. Nathan lives 1,000 meters closer to the school than Max. Nathan walks at 80 meters per minute, and Max walks at 100 meters per minute. They leave at the same time and arrive at the same time. How far is Max's home from the school? First, let's solve this with the equation method. Let the distance from Max's home to the school be x. Then, Nathan's distance is x minus 1,000. Their times must be equal, so we write x divided by 100 equals x minus 1,000 divided by 80. Solving this gives 4x equals 5 times x minus 1,000. That simplifies to 4x equals 5x minus 5,000, which leads to x equals 5,000. So Max's home is 5,000 meters from the school. Now let's solve the same problem using reasoning. Every minute, Max walks 20 meters more than Nathan, since 100 minus 80 equals 20. But Nathan lives 1,000 meters closer to the school. To arrive at the same time, Max must walk 1,000 meters more. If Max gains 20 meters per minute, how many minutes does it take him to cover 1,000 meters more? 1,000 divided by 20 is 50 minutes. So they both walked for 50 minutes. In that time, Max walked 50 times 100, which is 5,000 meters. Again, the answer is 5,000 meters. Now, the third problem. One day, Max walks to school at 100 meters per minute and is 3 minutes late. The next day, he walks at 120 meters per minute and arrives 5 minutes early. How far is school from his home? Let's solve this with equations first. Let t be the exact time in minutes that it takes to arrive on time. Let d be the distance. On the first day, Max's distance is 100 times t plus 3. On the second day, his distance is 120 times t minus 5. Since the distance is the same, we set them equal. 100 times t plus 3 equals 120 times t minus 5. Expanding, we have 100t plus 300 equals 120t minus 600. That simplifies to 900 equals 20t, so t equals 45. Plugging back, the distance is 100 times 45 plus 3, which is 100 times 48, or 4,800 meters. Now, let's solve the same problem using reasoning. On the first day, Max walks at 100 meters per minute and arrives 3 minutes late. On the second day, he walks at 120 meters per minute and arrives 5 minutes early. The difference in travel time is 5 plus 3, which is 8 minutes. That means when the faster Max arrives at school, the slower Max is still 8 minutes away. In those 8 minutes at 100 meters per minute, the slower Max would cover 800 meters. So when the faster Max finishes, the slower Max is still 800 meters behind. Think of it as a race. The faster Max gains on the slower Max at a rate of 20 meters per minute. To be 800 meters ahead, he needs 40 minutes. Therefore, the faster Max takes 40 minutes to reach school. At 120 meters per minute, in 40 minutes, he walks 4,800 meters. Now let's summarize what we have learned. All journey problems come from the formula distance equals speed times time. There are two main ways to solve them, the algebra method using equations and the reasoning method using logic. We also have two classic problem types. The first is the chase problem, where a faster traveler tries to catch a slower one moving in the same direction. The key idea is that the speed difference multiplied by the chase time equals the gap between them. The second is the meeting problem, where two travelers start from different places and move toward each other. The key idea is that the sum of their speeds multiplied by the meeting time equals the total distance between them. Finally, let's consider the last exercise. Max and Nathan leave their homes at the same time, walking toward each other. Max walks at 100 meters per minute, while Nathan walks at 80 meters per minute. They meet at a point which is 120 meters away from the midpoint between their homes. The question is, how far apart are their homes? I will leave that one for you to solve as practice. And that concludes our lesson for today. We saw how to solve distance problems using both equations and reasoning, and we reviewed the two important types, chase problems and meeting problems. With these tools, you can solve many real-world questions about speed, time, and distance. Thank you all for listening, and I'll see you in the next lesson.